Hi there students, welcome to Year 10 Science and Motion and Energy, and in this particular video we're going to be looking at speed and velocity. In the last video we looked at the difference between displacement and distance, and the main difference between those two was the fact that displacement is a vector and therefore has direction. Well, speed and velocity are another pair that work in a similar way. Speed is a scalar quantity, so it only has magnitude. Speed is a measure of how fast any moving object is travelling. And of course that includes objects that are stationary and therefore would have a speed of 0. The units of speed are meters per second. And we can define speed on the basis of distance travelled per unit of time. Hence a constant speed of 5 meters per second means the object will travel 5 meters every second. Or alternately, in 1 second, the object will have traveled 5 meters. They probably sound the same, and they should. So this is the way we calculate our speeds. When we're looking at speed though, there's two different types of speeds that we typically calculate. The first of these is average speed. Average speed is often calculated when we know that the speed is changing. It can happen that we calculate average speed when we know that the speed is constant, but then the average speed is also equivalent to the speed at any given unit of time. We can calculate the average speed by dividing the total distance which an object travels by the total time that it takes for the object to travel that distance. This gives us an average speed. Doesn't tell us everything about the journey, but it does tell us the average speed. The units for average speed are going to depend on the units for distance and time, although typically they will be in meters per second, as they are our SI units. Average speed can also be determined by the gradient of a distance versus time graph. To give you a bit of a look at some simple calculations, let's calculate the average speed of a car that travels a distance of 100 meters in 5 seconds. As much as you can, try and find the variables that you have been given in the question and then use your formula to solve. The formula can be put into a triangle. These sorts of simple formulas work very nicely in triangles because they allow you to find distance by multiplying speed and time, speed by dividing distance by time, and time by dividing distance by speed. So we can get to any of the variables in here very quickly by just putting them in a simple triangle. To use the triangle, we can calculate the average speed of a car that travels a distance of 100 meters in a time of 5 seconds by dividing 100 by 5. This gives us a value of 20 meters per second as the average speed. We can also determine the distance a runner would travel by saying that the distance is equal to the speed multiplied by the time. Now the speed in this case is 0.5. The time is 1 minute. But notice that we have non-matching units, minutes and seconds. In order to do this calculation, I have to change minutes into seconds, and I know that every minute there are 60 seconds. So I'm going to have to multiply by 60 so that my time units are in the same unit as the speed units, and therefore they will cancel out when I multiply through, and I'll get a distance of 30 meters. Average speed is just one way of looking at how we describe speed over a journey. If we're traveling in a car or in a bus, then often our speed is changing constantly from moment to moment. We may change from a 60 zone to an 80 zone. We may come to a school zone and have to drop to 40, and we may even get stopped at traffic lights where our speed might drop to 0. The average speed will tell us something about the journey, but it won't tell us all of these changes that occurred during the course of the journey. So sometimes we want to look at the speed at a particular instant of time. This is called the instantaneous speed. It can be measured in kilometers an hour, typically for a journey involving a vehicle, because speedometers are set to that unit. What it does is tells us a particular speed at a certain instant of time within our trip. And sometimes it gives us a better description of motion when we do this. Velocity is the companion to speed. It's the vector version of speed. And therefore it's going to have a direction. Because it's similar to speed and it's calculated in a similar way, it has similar units. So the SI units will be meters per second. But the difference this time is it will have a direction. So it may be north or up or to the right or whatever. These are directions and they are used to help us identify in which direction the object is moving as well as how fast it's going. When we calculate average velocity, we do it exactly the same way, average velocity, but this time we look at the total displacement over the total time rather than distance. Because these are vector quantities, we keep the vectors consistent. So if we're going to describe velocity from a graph, then what we're going to need to do is to identify a couple of important places on a graph. The simplest one, of course, is this section here, because the position doesn't change. The displacement is 0, and anything that we divide by 0 is still going to give us a value of 0. So the object is stationary. Between 6 and 8 seconds. However, between 0 and 6 seconds, what we have is a speed that has changed, that is constant throughout the journey, and our position has changed from being 0 to 4 meters north. If we say that the calculation of gradient, which is the slope of a line, is equal to rise over run, what you notice is the rise is equivalent to the position or distance, and the run is equivalent to the time. And this is the way we calculated average speed before. In this case, we would have 4 divided by 6, which is 2/3, or 0.67 meters per second. Now this would be a speed. In order for us to change it to a velocity, we would also need to indicate that the object is north of its original position. Therefore, we use the n to represent that. Thanks for watching.